Are you applying data science to that basic research? Yeah.
Huge amounts of data.
It's great. Great.
I feel like you guys that's
Alrighty, why don't we go ahead and begin? I
It's
think
nice
we
to
have
be in an
a forum
industry
here,
where
a
you
couple
know
folks
you're
that are
actually benefiting
coming on
society.
in here.
That's a huge
So I
contribution.
want to introduce myself. My name is Brian Gates. I'm the Regional Sales Director for MapR, responsible for Southern California territory. Colleague Carlos Ortega that supports me back there, and I know we've met a variety of folks here. So welcome to the Big Data event. This is something that we do worldwide. I think we've done 12 of these now. 500 different companies have been involved, and our marketing team that's running around, Michelle and Melissa, does a great job in helping to coordinate this. So we look forward to a productive day today on this. Also, I'd like to thank our sponsors. In the back here, you'll see tables from Datamir, Cisco, Splice Machine, ourselves, MapR, and Attunity. So please, as you have, want to learn more information about them, stop by their tables, and they have folks back there that can help you out. One thing, I vetted this story with my SC, so I hope it goes over well. But people ask about, big data and, what's the value of it. And this weekend I was playing golf with my buddy of mine. He's in the mortgage business, so he has no idea what, big data is and so forth. And we were teeing off, and he's probably played 100 rounds of golf with me, right? So he knows I'm a very average golfer. So sometimes marshals come up on golf courses as things get slow, right? So they park their cart and they watch and make sure everyone sort of moves along. And I hit a great tee shot, and then I put my approach shot on the green, and then I actually knock in a putt for a birdie, right? And the marshal's like, wow, he goes, man, you're a really good golfer, right? And I went to my buddy, right, who's seen me play 100 rounds. I go, this is what big data is, all right? I go, he's seen a very small subset, and he thinks I'm a really good golfer. You've seen me play a lot of times. You know that that's not true. So anyway, we hope that you'll learn more about that today as we go through a variety of different topics. Also, Jim Scott over here will have a book signing that's on the Getting Started with Apache Spark. That will be during our morning break. Some logistics real quick. We have bathrooms that are back here as you kind of go inside where the elevators are. Some bathrooms there. If you get bored, there is a pool and a hot tub out here, I think to the right, if you want to experience that. The Wi-Fi password is up here. Password information. Also, something that's very important as we do these big data events is there's a survey at the end, and that just helps us make the next one even better. And to kind of promote you to doing that, there's a Jawbone jam box that is a gift that we select from one of the folks. So if you can, fill that information out. So with that, I think, there's also validation for parking. So I don't know if any of you folks parked in here. If you didn't get that validated, please, come back to where you registered and we can provide that to you. And of course, if you want to learn more about, MapR or any of the other sponsors, please stop by our tables back there, and I'd be happy to have a more in-depth discussion with you about that. But I think the topics up here today are just more general and big data. So no further ado, I'd like to introduce Jim Scott. Jim is a director of our enterprise strategy and architecture, and his topic's going to be streaming in the extreme. So Jim? Well,
Thanks, Brian. I'm good. All right, so hopefully everybody's got the Wi-Fi information. I'm going to take it off. All right, so I have modified the title of my talk. It is now scaling and streaming in the extreme. So now you get more for your money. So, little background on myself before I get started. I am a co-founder of the Chicago Hadoop Users Group. I've been working with big data for about 15 years. I've been working with Hadoop specifically for about 7 years now. I've seen a lot of different use cases, and the information that I'll be sharing here in this talk comes pretty heavily from my background and different projects that I've worked on in this space. Probably the biggest scaling platform that I've worked on was scaling to 60 billion transactions a day in digital advertising. Being able to scale your platform is a pretty big deal. Scaling, making software horizontally scalable is important. The operations and the business processes that come along with that are equally as important and should not be overlooked. So if anything, I would encourage you to keep that in mind while I'm talking about this. And just as one additional reminder, I'm going to encourage you to just take a couple minutes at some point throughout the day and fill out the survey. It's one of those things that, at least my boss can go back and, have something to yell at me about. So, one of the things we're going to talk about here is going to be the Zeta architecture. We're not going to spend too much time on it, but this is going to be one of the components that you're going to look at for enterprise scalability. We're going to go through this, going to cover some background fundamentals, short little overview of the Zeta architecture, and then we're going to talk about pretty substantially messaging platforms and how you can build out a scalable architecture with streaming platforms. And then I've got a nice little story at the end. I like telling stories. So hopefully everybody's still awake by that point. So when we talk about building scalable applications, number one, it's not easy. Enabling servers to communicate with other servers is problematic in general. So one of the mechanisms that can be used to have these different services talk to each other is RPC. So remote procedure calls are a way to have a tight binding between servers. Decoupling that is a very important step in building a scalable platform. We want to take as much manual management of these steps and procedures out of the pipeline as possible. The more manual you have, the more likely you're going to have failure points, the more likely you're going to have a lot of people up at 3 a.m. worrying about things that would probably be better off if they were just catching some Z's. So fundamentally, this is my perspective, data is the problem. Now, I've had a problem with the term big data for a number of years. Now, it's fine, people use it to talk about and bring the conversation to something that everybody understands, but the term big data is it's kind of all over the place. The argument about what is big data is kind of a silly argument. So, when you look at this in perspective, if data is the problem, then enterprise architecture is the solution. So, taking into account at the very base of your solutions, what is it that's going to help drive your business forward? And since all of these applications depend on data, whether it stays in memory, whether it gets persisted, it's data moving across your enterprise. The size of it really doesn't matter. That could be like a little bit of a joke right there, but it's really true. Because whether I've got a terabyte of data, a petabyte of data, it doesn't really make any difference. So if you think about it and you come to the determination that size really doesn't matter, then one of the more important details here is when you prepare for success, you have planned for the future, and the goal would be to not have to go back and re-architect your entire platform when you have success. So what it comes down to is you don't want to lose your users when you're having to figure out how to scale your platform. Anybody here ever hear of Twitter? Right? Yeah, pretty much everybody. Has anybody here ever seen the Twitter fail whale? Yeah, I see some heads nodding. So it's an example of Twitter had massive success, and the fail whale was their error page. Well, they had to go through a pretty massive re-architecture to make a platform that could handle the scale of their popularity. Now, it's both good and bad, because the bad side was they lost a bunch of users. The good side was they went back and re-architected it so they could actually make it work. But it'd probably be better off if you prepared for success ahead of time, and then when everybody shows up at the door knocking, you're just ready for it, right? If it's a little bit of capital expense for more hardware, that's easier than having to go back to the drawing board and figure out how to change all your software to support scale. So, when we start talking about scaling, we really want to get rid of the data silos, because what happens in most applications is the data that's being generated, somebody wants to look at it. Somebody wants to do analytics on it. So we want to get rid of the pain from all of these different processes that we have. And I don't typically like to talk about swap out technology A with technology B, or B with C. I like to think about, start over and step back. Look at what your options really are. What are you really trying to achieve? If you can remove steps, processes, anything that takes time out of your procedures and how you operate, you'll probably be happier at the end of the day. So when we start talking about scaling, and again, taking this as kind of the opposite of just talking about big data, what are you really looking for here? Well, if you have more than one application server in your stack, or more than one web server, or more than one anything, you really get to this point of saying, oh, okay, so it doesn't matter if I have 100 gigs of data or a terabyte of data. If you need more than one server to accomplish your job, odds are we're talking about the same solution set now. I think in general terms, that makes consuming and understanding the concepts around big data a little bit easier. So as a part of this, when you suddenly have more than one of anything, you now need to understand and get your head around the concept of resource management. So when I was in ad tech, one of the things we talked about a lot was the distance between 0 and 1. So we originally started talking about this with dependencies on code libraries. Having no dependencies on external libraries, going from 0 to 1 is a huge deal when you start looking at your development procedures. Having to have your build pipelines build appropriately, make sure everything's triggering off properly, make sure you have proper integration testing. 0 to 1 is huge. 1 to 2, not so much. But 1 to 2 is the big problem when you start looking at scaling your infrastructure, right? You build your first application, now you come up to your second one, how do you make them all work? So the goal is, I want to make it as easy as possible for everyone to go from 1 to 100 as possible. And that's what we're really talking about here. So the Zeta architecture, the intent is to support elastic expansion and contraction of services in different tiers of your stack. I don't want you to have to do manual sharding. I don't want you to have to figure out how to manage where your traffic goes. So the best way to implement this type of scaling is with a messaging platform. So I've got this nice pretty diagram. I call it pretty, I made it. I had some help from others that are a little more thoughtful and artistic than I, but it's really pretty, I like it. So what we're talking about here, number one, in the very center, I have global resource management, dynamic compute resources. Now, this sits in the center of this architecture. It's one of these things that once you use it, once you have people comfortable with it, it can kind of fade to the background and just be there as like an administrative function of your business. But of course, it sits in the center of this because it actually touches everything in the rest of this architecture. Now, at the bottom, we see a common storage platform. It's extremely important to have a common storage platform in this architecture because as you scale, you cannot be constantly concerned with how do you get your data from A to B, how do you enable analytics, how do you enable real time. All of these things have to just become second nature. If you're concerned with them constantly, the architecture won't work. The next thing is, here on the left, we've got real-time data storage and application support. So, from an architectural diagram, this, I intend for people to generally use this as here's what we're looking at from a holistic view, but when you start getting into building out your own solution architectures on top of this is just a reference diagram for you. So, when you start looking at real-time application support, how you connect services together, right? The topics you define, your streams, where data is going to move. This is just telling you this is a component here. On the flip side, over here, we've got pluggable compute models and execution engines. Now, this is one of the more important facets if you put it in perspective of where the technology is right now in the open source industry, where people's hearts and minds are at. Spark is extremely popular. Apache Flink is gaining a lot of popularity. Apache Drill, excellent for performing distributed SQL. Hadoop MapReduce is what started it all. The thing is, these things change rapidly. They evolve quickly. So the goal here is that everything here has to be swappable. Because what people use on Team A could be very different than what people use on Team B. And the goal is that everything that works in this architecture to work holistically here has to play nicely in this box. So Team A, they say, we have to use Spark, this is where we're going, this is what we're doing. Team B says, that's great, but I need to be able to use Apache Drill. You don't want to have 2 copies of your data. You want to have 1 copy of your data. Both tools have to be able to read, have to be secured properly. You have to support the concepts of multi-tenancy, right? If I'm running Drill and I'm the least important person in the business and the boss says, hey, you know, Jim, screw him, but give him 1 CPU worth of compute. It's pretty important that you have the ability to globally resource manage, but also let him run his queries. They might be slower, but he can still do his job. And you don't have to move data, you don't have to find additional resources. The people running their Spark jobs, they're lucky, they get extra compute resources, yay for them. So next on this list, we get into the concepts of deployment management. So this is this container system up here. Now, I think Docker's nice, Kubernetes is nice, use whatever you want, doesn't matter to me. Again, this is another pluggable area. You pick what works for you, you plug something like this into your DevOps environment, you now have a way of delivering isolation into your environment that's different than creating physical static partitions of your hardware. Very important. Now, up here, I've explicitly called out solution architecture. This is probably the one thing that I get questioned about the most, is why do you have solution architecture in here? Well, quite frankly, in my experience, my history, all the companies I've worked at, enterprise architecture and solution architecture are nearly always blended and merged together on the first iterations of anything built in the company. Now, for better or for worse, what happens is when solution B comes along and starts getting built, maybe almost ready for production, people start saying, oh, but what are we going to do about backups? What are we going to do about recovery? Are we using the exact same systems that we had for solution A? Are we going to have the same backup and recovery strategy? What type of disaster recovery do we need to have? What type of business continuity solutions do we have to have in place? Well, the solution architecture logistically does not need to be concerned with those questions. That's part of your enterprise architecture. So I put it in this architecture, this enterprise architecture, explicitly to create a line between what is the enterprise architecture and what is the solution architecture. The last piece sitting at the very top is your enterprise applications. Now, I like to use a web server just as the general basic example here. Now, a web server usually runs on its own, is happy doing its job, sometimes has services in the back end that it proxies to. Doesn't matter, whatever you want to use it for. But it is an enterprise application. And with a web server, you can easily deploy it in containers. You can put that web server as part of your solution architecture that you're building for your business solution. And the data that it generates can go straight through to the file system. Or it could go through your real time. You could have those go through as messages, whatever you want, whatever you prefer, whatever your business requirements are for the use case. There's no explicitly right or wrong answer in that use case. But then, having that data land either here or here, being able to do compute instantaneously without having to perform additional data movement. Now, when I was telling you about that 60 billion transactions per day system that I built, we had to move logs. The architecture we used at that time was Apache Flume. We used Flume to move 60 billion log lines per day. I did the architecture, our team implemented it, worked great. It was a pain to manage. It's just an absolute nightmare to manage at that scale. Because what happens is when you look at a development environment, your configuration is going to be completely different than a QA environment, which is also going to be completely different than a production environment. Why? Because the shapes of the environments are going to be completely different. How you choose where your logs go between each of those different servers in your infrastructure change, and all of the server names probably change too. And because of that, all of the configuration that drives Apache Flume all has to be effectively manually controlled. That's kind of a nightmare. It's not kind of, it's an extreme nightmare. It can work very well from a performance standpoint, but having to build it, it sucks. When you look at this architecture cleans that up. And I want to reinforce that everything in this architecture is pluggable. Everything. Whether you're in the red, the yellow, the gray, the blue, the other blue, or the other blue. Now, there's one thing in this architecture diagram that only a couple people have noticed. And so since it wasn't being picked up, now I like to explicitly talk about it. Everything, if you look at this as sitting on top of it, if it was a physical thing sitting here, everything is sitting on top of the red. That red is supporting everything above it. Everything above the yellow and the gray is being supported by everything below it. Conceptually, when you look at it this way, it kind of exposes what your architecture really looks like, where your dependencies end up going, and where your data flows end up living. And again, come back to this global resource management, it kind of does just fade to the back. We'll have some time for questions at the end. So consider that when you're looking at how to build out a platform in the future. Now, since I talked about digital advertising, 60 billion transactions a day, this is basically the architecture that we had. So what we had here is we've got our web servers that we deployed in containers. We could deploy them anywhere across our architecture. The advertising engine, which is a brain of the system, it is a recommendation engine fundamentally. It's taking the traffic that's coming in, it's having user profiles that are coming out of our real-time storage here. It's pulling those in whenever a user hits. Generally, those types of things, they stay cached for some period of time because once a user comes in, they end up revisiting a few times and then they have a TTL on them to go away. The red lines between here, these were RPC communications in our model at the time. We did not have what we would generally consider a message-driven architecture with a decoupled messaging system. This was all RPC, and this was the most pain of anything in the platform to be able to handle for scaling, because it was all manually sharded. But when we start looking across here, the data could land via NFS, make it straight to the file system, and compute could be run over this immediately. The data that's there is accessible. So we flumed in our original, but then further down the road, this is the possibility of what could happen. So if you think about this in your own terms, getting rid of data movement is a massive time saver. It's a big operational overhead that you can get rid of. And then over here, I like to throw this billing system in here because I don't know about you, but most billing systems that are out there, at least that I've seen, they run in relational databases. Most relational databases would not support running on this shared architecture with the distributed file system. And I say most, not all. There's quite a few out there, or there's a number of them out there that will support this. But that billing system is going to sit somewhere else, and the odds are you're not going to share its resources. It's just going to continue to live the way it does. And that's fine. It has its place in the overall solution architecture, but that system, that server itself, is going to live outside the rest of the shared architecture. So, keys here. big takeaways, less moving parts. If you can create an architecture, diagram it, and show people how it works, the simpler the better, right? If you could take your enterprise architecture and take it to whoever is at the top of the business and they can understand it, that means you've created an architecture that is solid. If you can explain it to them and they can understand it, that's better, right? You get better resource utilization, which is very good when it comes down to capital costs, expenditures for the business. The isolation model is a really big deal when you start looking at dev, QA, production environments. So logistically speaking, you could run your dev, QA, and production all on the same hardware. Now, are you going to? Maybe not. I suspect most people would not be comfortable doing that in early stages of implementing this architecture. But logistically speaking, you can do it. You might still want some isolated instances for testing certain upgrade scenarios, but in general, you can share across this. This model is implemented at Google, and they deploy 2 billion plus containers a week. So fundamentally, you can use this for all of your problems. And then from an integration testing perspective, this was a really huge deal in ad tech, is we wanted to be able to get the data coming from production and pipe it through to the dev and testing environments. But it's a nightmare. You can't do it without a message-driven architecture, at least not in a timely, manageable way. You take some caption of it and you copy it over, and then you work on building some replay modules around it and try to plug that in and make it work. The problem is, it's never quite good enough as listening to the real data. When you roll out new code into production, you need rollback scenarios to be able to put the old code back in place when everything blows up. Well, it'd be nice if you could actually take that real data, run it through the real code in a different environment without having to figure out how to re-architect your whole platform. Well, that's one of the benefits of a message-driven architecture. And then again, the big thing here is shared file system. It really delivers a lot of benefits. The biggest thing that comes out of this is you get to the point of being able to deliver real-time systems. Now, real-time means you have the choice of what your SLA is, truly, right? Because people will argue all the time, well, real-time means it has to be less than a millisecond, or it's less than 20 milliseconds. It kind of falls into the same argument space as big data. But fundamentally, what it means is you get to pick and choose how quickly you consume it and when you consume it. That's the real benefit of a real-time system. Real-time means in time, you will really be able to do what you want to do. I just made that up. So my little reminder here is, this is one of the things that comes up a lot, is in that solution architecture box, one of the things I had in there was Lambda architecture. Now, whether you're a fan of Lambda architecture or not, I don't care. I'm okay if you're not, trust me. But just to be clear, Lambda architecture is a solution architecture. It's not an enterprise architecture. It's a mechanism for you to deliver a solution for your business. These two things are not the same. You could build a solution with Lambda architecture on top of the Zeta architecture. So most importantly, if there's nothing else you take away from this, I don't care if you use the term Zeta or not, it makes no difference to me. I just wanted a name that people could easily remember. But if you think of this as, it's plain and simple, it's a scalable enterprise architecture that enables real time, that's the key. So, messaging platform. Now, at the beginning, I said scaling and streaming in the extreme. So, what is extreme? Well, I like to really go out there and say, extreme is 1 trillion plus events per day. Now, that's a lot. A lot of people say, that's ridiculous, Jim. You're crazy. Who cares about 1 trillion plus events per day? Okay, it's fair. But what if I have millions of producers and, you know, when you start multiplying these messages coming through, you look at billions of events per second. Well, the generating systems generate events maybe in the millions or hundreds of millions of events per second, depending on your scale. But how many consumers do you have? How big is your consumer pipeline, right? How many different streams or topics are you creating for your whole pipeline? When you start adding these up across all of the different use cases you have, it can grow very quickly. So if I have multiple consumers and possibly every consumer consuming every event, it gets pretty big pretty fast. What happens if I look at multiple data centers? Now, it really doesn't matter what your business is. The moment that you need to go and get a second data center for disaster recovery, for business continuity, for scalability to support your customer base, whatever it is, that complexity is a drastic change. In ad tech, we ran 2 data centers, one on the East Coast, one on the West Coast. We had to do replication of user profiles between the 2 data centers, and they had to be less than 1 second out of sync. Because one of the things that happens in ad tech is you visit a website and you get a hit, you're served through this server on this coast. Because of internet routing, your next hit could go through the other data center. It happened all the time. It's one of those edge cases that you've got to be prepared for. So being able to handle that is a really big deal. And while I like to tell people plan for success, which we talked about before, you need to really plan for drastic failure. We had a scenario, again, in ad tech where we had the data center shut our power down on us. They literally cut the power. Every server in the data center, gone. So you have to plan for drastic failure. So keep that in mind. That is part of really extreme thinking. So what's the average reality here? Because this is how we've got to balance this out, right? We've got to put these things that I call extreme into focus. So if I have 100 servers and I start looking at the metrics that are coming through the servers, right? I want to instrument my data center. I want to know what the performance of these machines are, memory utilization, CPU utilization, temperature on the boxes, all of that great fun stuff. How quickly you want to sample those is going to be a function of how much data you generate. But when you start looking at log entries that come out of the applications, right? It sure would be great if you could have a holistic view of the logs, the errors, the warnings coming out of your applications, and you could see that in a central dashboard to manage your scalable architecture. All of these different things, just to the tune of 1 million requests per day, multiply this out, you're at 2 billion events per day. We got to 2 billion pretty fast. And I would like to think that most of these numbers are actually not overly aggressive. I think these are all very realistic numbers. And I think there's a lot of use cases that would push these numbers far further than what I've presented here. So when you start imagining the scale that we can look at and start thinking about the total number of consumers and the pipeline you build and breaking up the events between your services, it can grow very rapidly. So I don't think that my extreme thinking is really too far to left field, because if you're using this to handle communication between servers, you probably want to have some guarantees that you're not going to outgrow your messaging platform too quickly. Because if you're going to pay through the nose to scale your messaging platform, it's probably not going to be a very cost-effective way to decouple your services. So I just want to level set really quickly about the products that we're talking about here. In this space, there's only 2 products that meet my definition of extreme. And it's MapR Streams and Apache Kafka. So MapR Stream supports the Kafka .9 and forward APIs. Fundamentally, the difference here that we're talking about is ease of administration, general performance. I would classify MapR Streams as being nearly zero administration. Kafka is not quite. But from a performance standpoint, MapR Streams is faster, but it's not so much faster that you're going to say, well, it's just like, wow, it's huge. But I think I've got some performance numbers a little further in. So what we're talking about here is all your data from all of these different places coming through messaging platform. When you start looking at where the data goes, stream processes are hot, analytics is pretty darn important, and any general type of consumer to your data pipeline that you want to define, you can plug in. Simple APIs. So, 7 years ago, I would have considered, actually I did consider, not would have, 50 to 100,000 messages per second on a server was good. We were excited about that. We were getting probe points off of cell phones and digital mapping. That was awesome. We were so excited. But this model is blazing fast comparatively. So with 200 byte messages on MapR streams with 5 nodes, we hit 18 million events per second. So if you think about that in the general terms of needing to be able to scale and handle all your messaging throughput for your scalable platform, you can handle it with relative ease at pretty small numbers of servers, which is great because it makes it so you don't have to be concerned about how to scale it for what cost. And the last line here, this really, 1.5 trillion events per day at that rate with 200 byte messages on 5 nodes. So you can get the scaling you need. 3.5 gigabytes per second, that's a capital B. Right? That's a pretty big deal for volume of throughput you can attain. So the fundamental piece here is manual sharding is just not a great solution. And this type of platform really truly enables you to get the scalability you need at relative ease. So having lived through manual sharding, I don't recommend it to anybody out there. It's a pain, it's a nightmare. Things break very easily. And again, to reemphasize, when you look at development, QA, and production environments, when you've got this production stream that you can point to any consumer at the production data stream coming through, and you can spin up a dev instance of your new code and have it write to dev tables or dev files, whatever it might be, you now have the ability to consume that data. You don't have to worry about impacting your production environment to test because the throughput capabilities that are here support it. So you want to get easy scale out. Well, stream processing is hot. There's a lot of options out there. I joke a lot about how many of these projects are out there, how many of them are Apache projects. They all compete with each other for the same user base. I swear, and like I joke about it, but I'm not really joking that they seem to show up about 1 or 2, every 3 to 4 months. They're constantly coming out. I don't know why. The one at the top is the fastest, Apache Flink. Apache Spark has about the most popularity right now. Apex was contributed recently, September-ish last year. Storm is kind of starting to fall by the wayside because it's not extremely performant, but the API is living, and Flink even implements the Storm API now. Samza, pretty limited use cases, not bad. Akka Streams, completely open source, but it's not an Apache project. And then StreamSets is also open source, not an Apache project. And then, of course, you can just build your own. So in digital advertising, we potentially could have, for the performance, used something like Flink at the time if it were available. But due to the latency and the management of the platform, we had our own. But again, conceptually, it's pretty easy to consume off of these platforms and then to be able to scale out. So a lot of flexibility here. Now, it's worth walking through what happens when you start looking at what happens in the exception cases, right? Because everything's great when everything's running, but what happens when something dies? Well, in these different use cases we've got, we need to be kind of cognitive of what the failure scenarios are. And when you look at something like having decoupled services and you want to protect against something failing, well, what happens when your web server dies? Well, this is where you need to put yourself through an exercise of figuring out what your failure scenarios are. Again, I like web servers because they're so simple and pretty much everybody understands their use cases. So if I have my ad server sitting behind my web server, right? My web server fronts the traffic, that's my interface to the world, and it dies. Well, what happens today if your web server dies? All the connections that were to it go away. They disappear. Okay, so worst case scenario is that if this web server dies, your responses don't go back to the user. You cannot get better than that. So if you're using a messaging platform for decoupling it, it's really not a bad scenario. You can put topics in place to send your messages from the web server to the ad server, drop it on a topic. You can have custom topics set back up for each of the instances of the web servers to listen to. And the messages can come back around from the advertising engine to the specific web server that it came from. It's actually pretty easy. It's not overly complicated to set up. It's easy to manage overall. And so what happens if that web server dies? Well, you actually have the ability to be able to go back and see how many messages were in queue. So if you think about it from a from a debugging standpoint, going back and troubleshooting, what happened? Why did it die, right? Maybe it was just pure, luck of the day. But maybe there was one of those messages that actually caused your web server to crash. Well, by having the data in those streams, you've got the ability to be able to go back and inspect what was going on. That's actually pretty compelling, right? Because if you were just using RPC between these servers, you can't go back and inspect what was going on unless you go to the application logs and you had the right level of logging turned on with enough data there to be able to troubleshoot it. If you've got the messages here, you've now enabled yourself to do better debugging. That's a pretty compelling argument. I've lived through trying to debug these things. This is way better. And then if your ad server dies, well, you actually have the ability when it's decoupled to have other ad servers. Maybe you put delay times in place to have another ad server pick it up and respond. Now, in our case, our service level agreement was all responses had to be back in no more than 445 milliseconds. Now, if your ad server dies, odds are you're throwing the traffic away and you're losing, however many requests were sitting on it. Not really a big deal in the bigger scope, right? If I've got 60 billion a day coming through all my servers and I lose 1,000 because an ad server died, not a big deal. But again, you do have the ability to come in here in this case and see what messages it was picking up, and you could replay those and see if one of those messages is actually causing your ad server to die. Another really big compelling event. Both of those servers now have new debugging capabilities to figure out what's going on for you to troubleshoot. So when you look behind the curtains, what could be going on in this architecture is I've tried to use the most generic names possible here because it isn't about this being an ad server use case. It's about being any use case. Is these producers could very well be the web servers. It's fine. Interesting data. Because it's arbitrary. It's whatever matters to you. So you could have this process sitting here listening. That's your activity handler. Maybe that could be a billing service, right? All the logs that come back off the front end, those go into your historical data, and that's how you generate your billing, perhaps. In the center, maybe real-time analytics. Maybe that's part of your recommendation engine, right? Maybe you drop this message off. Maybe you have a bunch of different recommendation engines and you let them all run. Maybe they all produce messages back. And then that is how you determine what to send back up to the user. Who knows? Flexible. The results can land here. You can dashboard it. You can do anomaly detection, right? Dashboarding is something I think is often overlooked in early implementation stages, but it's pretty darn important when you get into scaling out a platform. You want to know what's going on and where it's going on. So having the ability to not move the data around to get access to it, pretty compelling. So, story time. Is anybody here familiar with shipping containers? 2 people, that's actually 3 people, that's pretty impressive. Most of the time it's nobody. So, let's just hypothetically say we've got this ship coming into Singapore, picking up containers. Gets loaded up, and it's off to Tokyo. Awesome. So, let's say that we've got this ship instrumented, and we've got every one of those containers instrumented. We can now track where those containers are, where they've been, along their entire journey. We get to Tokyo, some of the containers get off, some stay on, new containers come on, awesome. We now head off to Washington. Well, apparently, and this is something I learned last year, it is extremely well-known information in the shipping industry that containers fall off ships all the time. I didn't know this, but it's very humorous to me. I've never owned any of the containers, so I guess that's why it's humorous to me. But fundamentally, if the ship has been tracking this the whole time, then you would actually probably have GPS coordinates of where those containers fell off the ship. Perhaps. Maybe, maybe not. Maybe they could be recovered, who knows? Depends on where they fall off. So you get to Washington, you're happy, you're unloaded. Now, what do you do with the data? Well, these technologies don't have to only live in a traditional data center, right? I could put these technologies anywhere. I could put a few servers on this boat. They only take about as much room as this podium. That's pretty easy to find that much space on one of these boats, right? They've got plenty of extra space. So if all of those containers are emitting their sensor data off of them, their metrics, whatever information they're gathering, to the servers, I could have scenarios where I want to deal with where does my data live and who owns the data. It's probably going to fall down to who owns the containers and where was the container, which countries. They may have data import-export rules and restrictions, right? Pretty complicated scenario, really. Well, I may have a case where the data on these containers has to go between different locations. So when you think about getting the data between these, if you have these events coming through and they just sit in the messaging platform, and when it comes into the dock, if it connects wirelessly, wired, however it is, and that data can transfer off automatically, and then it can replicate to each of those locations in a secure way, that's not bad. It takes a lot of burden off of the people figuring out how to implement such a system. Enablement, it's a big deal. So to me, this sounds like something else, right? This isn't really just containers on container ships and shipping. So, number one, we have to have a foolproof way to do this. It's extremely important. Additionally, each of these ports, it's pretty important that each of the ports have access, because when containers are coming off, if containers that are supposed to come off aren't there, somebody's probably going to be concerned. You want to be able to perform analytics at any time. And then when you get down to it, this actually just sounds like it's a multi-data center time series data use case. Well, if you're running 2 data centers and you've got servers in 2 different data centers, you want to be able to perform metrics across all your data centers, right? It doesn't matter where they're at. It doesn't matter the specific down to the detail use case. It's that this is the same thing. Container ships, multiple data centers. So each of those containers emitting metrics is effectively just like monitoring computers in your data center. So when we look at something like time series data, these sensors emit their metrics. They go through some messaging platform, the container events, not to be confused with containers like Docker. But you have a collector on the other side, right? Aggregating the data, storing it, perhaps in the database. But now from an analytics perspective, you want to be able to perform analytics straight on the container events and on the database with aggregated information, right? Different use cases are going to give you requirements to go at the data in different ways. So this, again, data center monitoring use case is effectively what it is, but we've put it on a ship to manage containers. It could be the same thing if it's an oil field, anything for industrial manufacturing, they're all the same thing. So resiliency in the metrics collector is pretty important here, because since everything is coming through the messaging platform, you have the ability to scale on either side of that container, right? If you have 1 million containers a day generating metrics, you can figure out what your SLA is to collect all of those metrics, process them, aggregate them, right? Your service level could say you only need 2 metrics collectors to handle all of your events you have, because your service level is so wide open that you don't care. Or it could be so fine-grained that you say I have to have way more, so you can shard it out. But it's all automatic because it'll scale on its own. So being able to replicate the events between the data centers, it's pretty darn complicated. It's not easy to do. And with MapR streams, this is one of the benefits of it, is that you can actually have these loops, and it will automatically terminate the loop knowing that the event started in this data center. So if you say replicate from here to here to here to here, it'll terminate there and it'll say, oh, I've already got this. We're done. We're good. You don't have to give it to me. So security across this is another big deal, right? Depending on your use case, security may or may not be super important to you, but fundamentally, it's a requirement in this type of platform, because you're going to come across the use case where people aren't going to need access or supposed to have access to certain types of data. And then being able to perform the analytics on the different data sources all at the same time without having to do data movement is a huge benefit. With that, I remind you, the truth is out there. Does anybody get this slide? One? I have mixed a whole bunch of different sci-fi together. Yes, it is a complete mix, but it's all topically accurate. Can anybody identify what he's from? Doctor Who. Does anybody identify what this quote's from? X-Files. And it is not Spock, but he does kind of look like a Leonard Nimoy. So, with that, To wrap up fairly quickly, a lot of people don't realize this, but MapR does offer free, as in beer, on-demand training. It's not just boring videos that you watch and watch someone else do something. It's fully interactive. I would strongly encourage you, because there's a lot of topics that are covered out there, ranging across Spark, Drill, HBase, MapRDB, MapR administration, Hadoop administration in general, developers, administrators level. That's it. Does anybody have any questions for me? We've got a couple minutes before the next presenter.
I have a question.
Yeah.
My name is Krishna Kashyap. I work for IBM, your friends. See, what is unique about this? Are you trying to say something MapR specific